Welcome everyone. I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 2220, which is minimum bit flips to convert number. Let's see the problem statement. A bit flip of a number x is choosing a bit in its binary representation of x and flipping it from 0 to 1 or 1 to 0, either of them. And for example, x is 7, so binary representation is 111, and if we flip the first bit from right hand side, we will get 110. The second bit, if we flip it, we will get 101, like that. And given two integers, start and end, and return the minimum number of bit flips to convert start to end, like start to goal. So our goal will be fixed. We need to flip the bits in our start variable, and we need to make the start to goal. And here is the description. Here is an example, like start is 10 and goal is 7. So the binary representation of 10 is 1010, and binary representation of 7 will be 111. So we need to make 1010 to 111. We can exclude the left hand side. If two variable binary representative is not in the same length, we can put the zeros in the left hand side of the smaller variable. So here smaller variable is 7, so we can put 0 over here, because we need to make the length of the two variables equal in its binary representative. So here we need to first flip the first bit from right hand side to make it 1. It will be counted as 1 flip. Then we need to flip the third bit from right hand side. It will become 1. It will be counted as second flip. And the third flip will be, we need to flip the fourth bit from right hand side. Then it will become 0, and it will become 0, 1, 1, 1. So it is the binary representation of 7. So that's how the answer is 3. And the constants are start and goal will be up to 10 to the power 9. So you can understand, we need to make the convert the integer values to its binary representation. Then we need to compare in the places, like how many places the start and goal is not matching. Like if start is 1, goal is 0, or start is 0, goal in 1 in its binary representation. In how many places it is occurring. Then we need to return the count, and before that we need to make the length of the binary representation both of the variables equal. Like if it is one is 100 and one is 7, so we need to put zeros before the 7 in its binary representation to make it equal. So you can use bit set also. It is a easier to do bit set, but I will show you using array also, so, or vector. So first we will check the vector, how we can do that. So we can understand it will be 10 to the 9. So let's make it 32-bit integers. So we will put 0 if it is not a bigger number. We will put 0 at the before in the binary representative. So let's make vector in, let's say for start it is v1, and the size will be 32, because we are making 32-bit integers. We need to store 32, maximum of 32 bits. And let's say for goal it is v2, which is also 32-bit integers. Now we need to put the we make the binary representation of start in v1. So let's int I equal to 0, I less than 32, I plus plus. It will be going from 0 to 31 index, and also we will perform up to the start is present. To see start is present, we will just put start over there. It will, if the start becomes 0, then this for loop will not work, and by default all the values will be 0. So we will put v1 of I is equal to start mod 2. To get the last value, it will be 0 or 1, and then we need to divide the start, divide equal to 2. That's it. And same as for the goal also, int I equal to 0, I less than 32, and goal is present up to then I plus plus. V1 now, V1 of I will be goal mod 2, goal will be by equal to 2. That's it. Now we got the binary representation of both of them. Now we need to count in how many positions they are not equal in its binary representation. The bits are not equal. So let's say answer is initially 0. Now for in I equal to 0, I less than the maximum index is 32, 31, that means less than 32, I plus plus. So we will check if v1 of I is not equal to v2 of I, then I will make the answer plus plus. That's it. Now we need to return the answer. So let's see will it work or not. It is accepted. Let's submit it. So you can see it is accepted. Let me discuss the time and space complexities of this algorithm. So this first for loop will be running maximum of 32 times or up to the start is present. That means the length of start. And the second for loop we also running the length of goal. Length means the number of digit present in goal if we see its binary representation. And this for loop will be running 32 times. We can say it is constant. And these are also you can say constant because maximum we can say 32 times it can occur. So overall time complexity you can say it is big of constant or big of 1. And the space complexity is also we are storing maximum 32 bit in like 32 bits. It is not depending on any of the length or any of like start and end, which is not variable. So it is 32 is fixed and constant. So you can also say the space complexity is also big of constant or big of 1. Now let's see how we can do that by bit set. So to use bit set, it is inbuilt. You can just put like bit set, and it as we are storing 32-bit integers, so we need to specify the bits, how many bits. So 32 bits, and same as like v1 will be start and v2 will be for goal. It will internally make a bit set means like convert the start in bits in 32 bits integer, and it will convert its binary representative to v1 and for goal also in v2. That's it. Now we just need to check if v1i is not equal to v2, the answer will be same. Just make it here. It will also can work. Let's see will it work or not. Then I can change. So it is accepted. Let's submit it. So it is also accepted. And the time and space complexity will be the same. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.